Kirumbi Engineers Skills Academy. We are available at Dar es Salaam, Tanzania, East Africa. You may contact with us through phone number +255 737 72 1910 or +255 787 85 74 85. Email us kirumbiengineering@gmail.com. Website kirumbiengineeringacademy.ac.tz. Now, let's continue to how can the procedure be for the moment distribution method. Now, the flow chart for the moment distribution method is as follows. The first procedure is to calculate the distribution factor df, in which the df, which is a function of the k at the point or the member over the summation of the k joining the members. For after calculating the deflection factor, now it can be followed with the fixed end moment. Now after calculating the fixed end moment, should be followed with how to calculate the balance moment at all joint free to rotate. After that, evaluate the unbalanced moment and then find the distribution moment. After that, find the so-called carryover moment. Then you repeat the above procedure with the two until the unbalanced moment is going to be 0 or a negligible values. After that, find the final end moment to any of the joint. So on that, after that one, you can compute the shear force and you can determine the reaction of the support, and then you can draw the shear force diagram and the bending moment diagrams. Now let's have an examples in order to be clear on these procedures. Now let's have another examples. For example, determine the reaction and you draw the shear and bending moment diagram for the two span continuous beams as shown here. Now consider a fixed beam having a fixed point at point A and C, where point B has a roller support and having the value on the left 18 kilonewton and 2 kilonewton per feet as a uniform distributed load. So the value for the length is given in feet, it is in empirical. So now let's continue on how we can use the procedure to go on. Now don't forget the member has a uniform modulus of elasticity in which has got a uniform cross section, so it is considered as a constant values. Now on that, the procedure is as follows. Now the first one, find the so-called distribution factors. The distribution factors, as we did before, or is from the formulas, it is a function of the k for the member, say the member between A to B or BA. The member AB, because it is a fixed, it is a 0 distribution factor, but the member between B to A, it is a function of a k at BA over the summation of the k regarding to the member, Now the value of k, it is a function of I over L. Now the value of L between these two points, it is about 25 feet. So it is this one values. Now after that, what you can do, you have your KBA and KBA sum to KBC. The ratio you got about 0.545. The same you can calculate the K value, between BC, which is a function of K between BC over the summation of KBA and KBC. Now this is the KBC and this is the KBA and this is the KBC. So the ratio you got again about 0.455. After that, you sum the value. On summing the value, the ratio of the K at any joint, if you sum, the distribution factor should be equal to 1, or it is 100%. So you can check in order to know whether it is you're in a correct way before continue. Now after finding the distribution factor as the procedure needs, now let's continue on the table. How can you put in the table? So as we said, for the fixed end support, the distribution factor is 0, and also at point C, it is a fixed end support, the distribution factor is equal to 0. Now if here it is 0 and here it is 0, it means at this point the value is 0, and at this point the value is 0. Now it is a support. If we remember, the distribution factor between BA, it is about 0.545, and at this end it is about 0.455. So the summation of the two value at the joint is equal to 1, as we said above. So on keeping it, this is the distribution factor on the table, how to keep it. So it is 0 here, it is 0 here, so this is the summation at the joint be the distribution factor. So on that one, you may continue to another procedure. So the second procedure, as we said, is to find the so we call the fixed end moment. So find the fixed end moment as the normal procedures. So how can we calculate the fixed end moment? So by considering this point, it is fixed, and this point is fixed, and having the point load as shown here. So the formula is the point load times the value, the first value length, times the square of the second value b, so over the total length. The total length is this one plus this one, which is 25, the square of it. So on finding, you get about 64.8 kilonewton feet. This is about this direction, or it is a positive value. After that, you continue to find the fixed end about BA. It is the opposite of AB. So the way how to calculate, now here the value of load there, you times the value of A square. Now the B is not now square, while here B was square, A is not square. So look on the how we put the value. So it is generally we say the load times A square B square times A B square over L square, once you consider on the point AB. And the opposite is if we consider the fixed end moment between BA. Now the load times A square, B is not square, over the total length as we did. So the value here, it is negative, so it is going this way. Now another way you calculate another followed moment. This one is already obtained, and this one is already obtained. So finally on the member BC, the member BC, it is uniform distributed load. So you can calculate it, the function of W. The W it is the load, kilonewton per meter or kilonewton per feet, times L square over 12. So the value it is about this one, kilonewton feet. Now this is a positive value, the direction is above. So the opposite one, it is, but it is in negative value. The direction is in this value, so this is a negative value. So you calculate clearly after calculating the fixed end moment. So you put in the table as follows. So how to put it on the table? This is the first law. It is a distribution factor, as we did here. It is 0, here it is this value, here it is 0. So the second law, it is the fixed end moment you calculate above. So this is the moment between AB, which is a positive, and this is the moment between BA, which is a negative, and this is the moment between BC, which is a positive, and this is the moment between CB, which is a negative. So you create your second law, which is a fixed end moment. So generally, the first law, it is a distribution factor, which is this value. The second law, it is the law for the fixed end moment, in which you calculate from the load as given for the support condition. Now let's continue for the following procedures. After calculating it, now you come to the third procedure, and the third procedure, it is a consideration for the distribution factor or distribution moment, or the moment distribution. Now since the joint B, it is not clamped now at this joint, now we release the joint and we determine the so-called unbalanced moment. Now it means for this joint, joint B here should be balanced, because as you see, the first value it is positive, the second value it is positive, now this is negative and this is positive. Now this is come to this direction and this come to this direction. At equilibriums of the member should have equilibrium here, should balance. The moment should be balanced. So the summation of the left moment and the summation of the right moment should be balanced. So if you sum it, it is about this value, a negative, sum with a positive, so the value it is remain positive. It is about 106.8 kilonewton feet. So this value, in order to balance, should be counter have moment which is in the opposite value. It means should be times by a negative value here in order to balance to the counter moment. So what can you do? Now what you can do, now you come above here. Above here, as you see, you have your ratio here. The first ratio is this one, the second ratio is this one. So this ratio should be countered with the opposite of the value which you sum here. So the opposite of the value which you sum here, you times by this value, you get the counter moment. You times by this value, you get the counter moment. The counter moment times the distribution factor is the so-called moment distribution values. So let's proceed. Now on proceeding, we shall see here the distribution moment, it is the function of the unbalanced moment at that joint times the distribution factor. Now this is the distribution factor and this is the opposite of unbalanced moment. You remember this is the positive one and this one should be a negative. The negative means the opposite of the unbalanced in order to have equilibriums at that joint. So this is the distribution factor times the opposite of this one. So the value is negative, this one. So the second joint or the opposite joint BC, the same distribution factor times the opposite of unbalanced, this one. So the value here it is this one. Now on calculating, you can have your value as you see there, this value and this value. So it is a negative because it is counter clockwise. So this one you have the third law. Now you put on the third law as follows. Now on putting it, you shall have the balanced joint B. Now it is this value and this value after calculating the unbalanced moment times with its distribution factor to each point. So now this is the third procedures. Now we continue. Now the distribution moment after having the value above, which is the balanced of joint B. So how can you distribute? How can you distribute? The distribution is the function of your fixed conditions, whether it is a fixed support. If it is a fixed support of the member between the first point, say your first point here and the second point is here. Now in order this point to distribute to the second point, you take the value of moment here, you do times by a half to go to that point. And if you want to distribute the moment, fixed end moment from this point to the second or the first point, you take this moment, do times by a half, distribute it to the another directions. So by that way, the value of BA should be transferred to another fixed joint, joint A. So how can you transfer it? You times by a half of the value. So you take this one times by a half, you have a negative 29.1. Also at CB, you transfer it by a half times the distribution moment at BC, which is a negative value. So times there, you get this one. So this one you create another law, which is the value now it is free to rotate in order to distribute the moment to the second value. I mean it's the second joint. So what you can do, you can see here the another law. The law now is this moment here is transferred by a half to this point, and this moment here is transferred to a half to the joint. It means the moment from here is transferred to this joint, and the moment from here is transferred to this moment. Now since it is, if you restraint here, it is a fixed support. So if it is a fixed support, the value how to transfer it is a half. It is a half from the value. Once it was a simple support, it means spring support, the transfer value it is 0. So by this way, it is a half from that value from the joint B. So here you create the so-called carryover moment. Now let's proceed. After having the carryover moment, once if you want to end on that one, you can sum now. You can sum now if you want to end. Otherwise, you can repeat the procedure until the value is going to negligible. So this one add with this one, you go to the final moment, this one, because this is a negative and this is a positive. The same applied, this one add with this one, you have the final moment negative, and this one add with this one, you have the final moment this one. Note that at the end B, the moment should be balanced, so the opposite moment will be equal to the same, or the summation of the moment should be equal to 0. So otherwise it is unbalanced. This one is negative and this one positive. So the clockwise moment and the anti-clockwise moment are equal and the opposite. The same applied on the right one, CB. If you add this one plus this one, you have this one. So on that way, how to create the so-called the final end moment. So the final end moment is this law. After summing this column and this column and this column and this column, so you have the final end moment. So by that example, if you want to proceed, you can proceed more by following the above step. So after that one, you can create the so-called the member, the end here, the reaction, meaning you can draw the shear force diagram and the bending moment diagram. So that is how you can proceed by another slope deflection method. So that's the way how you can do on that one. Another way, you can go to second examples. For the second examples, you can do the same procedure. Let's look. Now, the second examples, we say that they determine the reaction, draw the shear force, the bending moment diagram as shown. So the value now is shown here below, which is, the left one you have 80 kilonewton, and the right one with a lower support here, and this lower support, and the value there. As you see, the value for EI is 1.5, and the value here is I. So where E is the constant values. Now the procedure is as follows. Now the solution. The first one, as we said, now find the so-called distribution factors. Now find the distribution factor at joint B and joint C. Now on consider the continuous and the free to rotate. So how can you do? If the point B it is free to rotate, the procedure is as follows. Now the distribution factor between BA, it means this or this direction to this direction, because A to B, if you consider A to B, if here it is fixed here, it means this point the distribution factor is equal to 0. So the consideration is B to A. So once you consider the distribution factor between B to A, it is the K to between BA and the summation of the K at that joint. So this is the K between BA, and this is the K BA, and this is the K BC. So the value is about 0.6. So the same, you can calculate the BF between BC, which is the value of KBC, add to this value. So this one distribute by the ratio, so the value is about 0.4. So if you add this one and this one, the ratio is equal to 1. So you can proceed after finding the K value. So go to joint C. Joint C, find the K value at joint C. Now you remember the K value at joint C is the same as finding a CB, C to B, and note that here it is a simple support, it is a roller support or hinge support. So the value now here, it is, we say always is equal to 1 for the roller support. So how it means here it is fixed and here it is restrained, it is a roller support. So the value is K CB for the member over K CB. So if you have the same ratio, is almost equal to 1. And this is from the above formula. If you remember, K for the simple support, one end, it is equal to 1. So continue. You have already the value here and the value here. So let's continue. Now the second procedure, as you remember, is to find the so-called the fixed end moment. The fixed end moment is here, you consider it is fixed. So take this and this one. Now find the value. If you find the value there, go to the normal procedure. It is equal to PL over the ratio. So what you can do, the P is this one. The L is the summation here. The value, the formula is equal to PL over 8. So refer to the general formula once it is fixed there. So the value of P is this one, the L is this one over 8. So the value get positive because it is going this way. So the opposite one, this is the value for A to B. So find the value between B to A. B to A, it means it is opposite. It is clockwise and clockwise moment. So this one goes to this value, and the value should be a negative one. Now proceed on finding the member AB and BC. Here there's two values here. If you remember, there's two values there. The first value is, if you see this member, the first value B to C, B to C, B to C. If you find there B to C, I'm sorry, this is should be read up B to C and not A to B. This should be read up B to C. This one should be read up B to C and C to B. So the same procedure on finding there. So you calculate this one, you get this value. You calculate the second one, you get that value. Now after finding there, you keep that on the table as we did before. So the first law, as we said, is the law for the distribution factor, which is here 0, here is 0.6, here is 0.4, here is 1. So the second law, as we said, the fixed end moment, here is positive, here is negative, here is positive, here is negative. So on proceeding, you go to the second, the third procedure. The third procedure, as we said, is to find the moment distribution. And how to find the moment distribution is to take the restraint joint. The restraint joint there is almost the joint B. As you see, joint B should be released and balanced here. So here should be balanced as we did before here. So in order to balance, you must add this value and this value to have the unbalanced moment. If you add this one, you shall have the negative value. And if you have the negative value should be times by a negative 1 in order to have a balanced one. So the value which you times by a negative 1 should times by a distribution factor in order to have the distribution moment. So let's proceed. After having it, create the table. So as we said, take this one, you add the value, you have the negative. Now this one should be times by a negative 1. So the unbalanced negative times the distribution factor, you have this value, because this one times this one. And the same, this one times this one, you should have this one times this one, you get this one. And this one should have it's low, the unbalanced one. So how, and also the distribution factor to CB should be times by negative 1, because that one, if you see here, go to point C. If you see on this point, the value here, it is a negative. So in order here to balance, should be opposite one. The opposite one, the opposite of this one should be a positive. So times with the distribution factor. The distribution factor at this point is 1. So should be a positive 50 times its distribution factor, which is 1. So should remain the same 50 kilonewton feet. So now create the third law. The third law should be like this one. As we said, this one and this one at joint B, and this one at joint C, because the unbalanced one should be a positive one, a positive 50 times 1 should be equal to positive 50. So create it on the table should be like this one. So as we said, the third table now should be the balanced joint, and the balanced joint should be on this one and this one. Now here we should now take the consideration for the so-called carryover factor. So the carryover factor, as we said, whether it is a fixed support or not a fixed support. If it is a fixed support, we say we transfer by a half from the joint. We transfer by a half. And if it is not fixed support, the transfer is equal to 0. So let's look. Now go to the so-called distribution moment. The distribution moment, as we said, it is a function of a half times the distribution moment from the so-called a carryover factor. So once you times it, you go until the value should be equal to small. So after doing that, sum the column to have the final moment as we did on the above examples. So you can proceed like this one. Now the procedure now you can see like this one. The first one, the first law, as you say, it is the distribution factor. The second law, it is the fixed end moment, which is this one, this one, this one, this one. So we have now the so we call the unbalanced. In order to have unbalanced, it means you sum this joint. The value can have a negative. Now the value of negative can have a negative 50 times by negative 1. After times the negative 1 times with its distribution factor, you have this value here, and you have this value here. Also for this value, for this joint, you have this moment. If you sum by 0, you have a negative 50. That is the negative 50, it is unbalanced to this joint. So the unbalanced negative 50 times by negative 1, you can have the positive 50. The positive 50 times with the distribution factor 1, you remain with positive 50. After having the positive 50 here, it means you create this law, you create this law, you create this law. So what to do? Once you do the so-called carryover factor, the carryover factor, you take the balanced joint moment times by half if you transfer it to the fixed support. So what you do is to take, say, this one, it is 50 times by half, you have 15 positive, and this is 20 times by half, we have 10, and this one is 50 times by half, it is 25. So after having this law, and now this law, this another law, this one, if you see this one, it is a law. So this law times with the carryover factor. If you times 25 with the carryover factor, 0.4 times 25, you shall have 10. But this one 10 should be times by a negative in order to balance, as we did before. In order to balance the joint, should be times by a negative in order to balance. So the same applied in order to balance, because the value here, in order to balance, as we say, this is 25. In order to balance, should have a negative 25. Now this one times by 0.4, you create this one, and this one times by 0.6, you have this one. It means if you times 25 times by 0.6, you shall have 15. And this 15 should be negative because this moment should be balanced, as we said before. This one should be balanced to the joint. So in order to balance to the joint, here it is 0. So you take the value here, which is 0 here, you add with 25, you have a positive 25 times by negative 1 in order to balance at equilibrium to joint B. So a negative 25 should be created as an unbalanced moment. So times the carryover factor, and this point you shall have 15 negative, times the carryover factor, you shall have a negative 10. The same way you use on this point. Here you have a positive 10 as an excess moment. So in order to balance in this joint C, you should have add with 0. If you add with 0, you shall have a positive 10. So in order to have a balanced moment, should times by negative 1. The negative 1, you can create a negative 10 moment. So a negative 10 times by the distribution factor, you shall have also a negative 10. So the same procedure can proceed here. This value here, a negative 10, times by a half, you shall have this value, and this one times by a half, you shall have this value. This value also times by a half shall have this value. Now you have another row. The another row is this one. The law now is the carryover factor to the second. So this is the law here. And this law, as we did above, this one should be added with this value here. The value here is 0, so add with negative 5, of course you get negative 5. And negative 5 times by negative 1, which is an unbalanced moment at this joint. So a negative 5 times by negative 1, you shall have a positive 5. The positive 5 times the carryover factor on this point, we have this one, positive 2.5. And the negative, the positive 5 also times by 0.6, you shall have the negative 5, the positive 5, as we say, the positive 5 here times by carryover factor, you have this value 2, and this also times the 0.6 here, you shall have 3. So the same way here, if you add with 0, you shall have a negative 5 times by negative 1 in order to have the unbalanced to this joint, you shall have a positive 5. The positive 5 times the carryover factor here, I mean the distribution factor, you shall have the positive 5. So after having it, you create another law. The law now is this law here. After having this law, the same way, carry over the carryover factor in order to distribute the moment. So the times by half this one, you shall have positive 1.5, and this one times by half, you shall have positive 1, and this one times by half, you shall have this value. So repeat the same procedure as above. Find the balanced moment in this joint. So if this is a positive, so as we did it before, add with 0 from here, you shall have a positive, times by negative 1 to have a balanced moment, you shall have a negative 2.5 at this joint B, times with the carryover factor here, you shall have a negative value here, times with the carryover factor there, you shall have a negative value, this one. So repeat on this one, the value should have unbalanced with the negative 1. The unbalanced negative 1 times with a distribution factor here, you shall have only a value of negative 1. Repeat the procedure above by taking the carryover factor, a half of the value, take this one to this one, should be a negative. That value, take this one to this one, should be a negative 0.5, and this one to here, should be a negative 0.5. Repeat the same procedure until the value is negligible, is nearer to 0. So if you see here, the value now, it is about this one and about this one. If we proceed, you proceed longer. So you proceed the value until you get this one and this one and this one. So it is about 0. It is a negligible value. So after having your negligible value, now what you can do, this negligible value now, you can end at that point, or you can proceed until you have 0.00 something, so which is 0. So after having a negligible value, now in order to have the total value, it is the summation of the column moment. Now the summation of the column moment, the summation of the column moment, the summation of the column moment. So if you add the column moment, you shall go until you see now, if you add this one, end result is about this one. Sorry, the end result is about this one. The same way, if you add this one arithmetically, the end result is about this one. So the same way, if you add this column here arithmetically, if you add this column arithmetically, the end result now become this one. Note that if you have the same joint, the clockwise moment is equal to anti-clockwise moment. It means this value here, and this value here should be equal and opposite. And this value, as you know, as a normal procedure, this is a pin support or hinge support. if it is hinge support, it means the moment at the hinge support should be equal to 0. So here always should be equal to 0. So the same way, the same procedure, if you add arithmetically this value, the total end moment, if you add arithmetically, you add it well there arithmetically, add this value here, the total moment, the summation of all moment should be equal to 0. So the value here, if you add it arithmetically well, this should be equal to, the end moment should be equal to 0. And this is go with the normal procedure or the normal general rule. This is the so-called joint C. It is a pin support, and if it is a pin support, it means at this joint of point C, because it is a pin support, almost should be equal to 0 moment. At joint C should be equal to 0 moment. Here should have an equal and opposite moment, and here should have a negative moment. So that is the way how you can go with. So the end value, the end law, the end law should be so called the final moment. So after having the final moment, you shall put your moment here, 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 you shall put the opposite one there, you shall put the reaction there. So given the force as before, so you are able now to calculate the shear and the reaction. So it means in order to calculate the shear and the reaction, it is the normal procedure. Taking moment at this point, you can have this reaction. Taking moment at the support, you can have the balanced here. It means the reaction here, or the summation of y is equal to 0. If you balance, it means you can have as a reaction there. So, or you can have two simultaneous equations after having taking moment and taking the vertical reaction. So after having the simultaneous equation, you can solve this, and hence is able to calculate the shear as normal procedures. So as you to go through with the normal procedures, it means once you go through, you can have your reaction. So you can easily have your moment. So by having those, it's simple to go through and find the so-called the shear and the moment diagram. So here you can see now is able or simple to create your shear diagram like that one, created from these forces, because already the reaction you can calculate by normal equilibrium equations. So after calculating there, you can have able to calculate your shear. The value for shear, as you see here, it is this value, and this value, and this value, and this value. So this is between the two members, and this is between the two members. So this is the shear diagram as seen in this diagram like this one. The same way, after having your shear diagram, is able to calculate or to have the so-called the bending moment. So now it's easy to calculate the bending moment, because the bending moment is the function of shear or the function of the force is seen there. So here now is able to calculate the so-called this was your force, and now you can calculate the bending moment like this one. So your bending moment now can be created there, like as you see here, and this is the value of the bending moment. So you can see the maximum bending moment, it is there at the middle of the load, because this load is very and this load, if you see, the magnitude is bigger, the magnitude of the load here is bigger than this one. Automatically at this point should be created the maximum bending moment at the middle. So go on and create your bending moment free body diagram like that one, and above, as we did, you create the shear force diagram like this one. So having your shear force diagram and bending moment diagram can be easy to know or whether the maximum bending moment it is where can be created. The middle you can see, and the support you can see there. It's easy now to go on with another procedure. So this is the end of example number 2 as we did. So we can go and look another examples. Another example, as you see, it is here. This is the value given in empirical, but the support now, the support condition here, it is pin support. Here is roller support. Here is roller support. But this one now, it is have more than span. The first span, the second, the third. So you can pass through as in a normal procedure as we did. So normal procedure as we did, as you remember, the first procedure you create the so-called DF, and the DF at the joint should be created by considering the supporting condition. As you remember, here this is AB. So look for the support between AB, the joint A, how it is. The joint A, it is a roller support. Whether it is a roller support, the distribution factor is equal to 1, if you remember. And this here, the distribution factor is equal to 1. Here should be calculated, here should be calculated depending on the formula. So let's look. Here should be 1, and here should be 1. Be careful. It depends on the supporting conditions. So joint B, you create on the formula, you get there. But joint A, it is a supporting condition which is pin support, and here it is pin support. So if it is a pin support, it means its value there should be 1, and its value here should be 1. So the condition of the way how the support condition should be much considered. So look on the condition. So on calculating, you shall have the value here at the joint B. So the procedure you can go on, and there at joint C, as I said, the support at joint C, if you see at joint D, joint C is the same as joint B. You can calculate by normal this procedure. You can have your value, because this support and this support, if you restrain here, should be fixed. If you restrain here, once you restrain here, look, if you restrain here and here should be fixed. But if you restrain here and here should be fixed. Here is roller support. And also if you restrain here and here should be fixed. Here roller support. So the value for the roller support, as I said, a distribution factor, its distribution factor is equal to 1, and here is equal to 1. Here should be calculated from the formula, here should be calculated from the formula. So the value is here, the value is here. So the same way, as I said, because this end here, it is roller support, its value is equal to 1. So be careful on calculating the distribution factor. It depends on the supporting condition. So on proceeding, the normal way, find the fixed end support as a normal procedure. The fixed end support can be calculated as depending on the fixed conditions. So carry on there by looking the formula regarding for the support on each member or each span. So after having there, the end condition should be considered also with the deflection. If you see there, if one support is settled, the deflection also should be considered. So the value it is in empirical, so you can have the displacement there. So look on that one. After that one, you can proceed. You add the value by fixed end moment by considering a slope deflection with consideration of the support C. It is settled. So this one, it depends on the question. So read carefully the question. If you read for the questions, if you look for the question, there is some settlement about that one at support B. So if we hear it is settled, it creates deflection. So look and read the careful for the question as it is. Don't claim. So if you look the question, it is considered also the settlement at joint B. So after that one, you can pass it through on how calculate the fixed end moment, and it is the value, other value it is here, whether it is EI and E and I, it is there. So pass it through and look. So here we consider also the settlement. So the formula for the settlement is, you pass it through, it can be in this way. It is the function of the 6 times EI times the settlement over L square. So give the value there, because it is empirical. You can have the first fixed end moment AB and BA. Also fixed end moment BC and CB, it is in this function. So the length there you have. So create the value, regardless it is empirical. If you create there, you shall have there the value, it is about this one. Now after having your value there, which is the empirical, you shall have the fixed end moment like that one. So pass through, this is positive, this is positive. So after that one, as the normal procedure, you calculate there also the member CD and DC. It is opposite one. Go pass through for the formula and you put your value, it is a negative value. So after that one, you already have your fixed end moment. Now the fixed end moment, it is due to the external load. That was due to settlement. For find due to the uniform distributed load. So due to uniform distributed load, it is normal procedure. This is uniform load. So it is W, which is this one, times by L square. The span is this one over 12. So this is also, it is positive value. So find for each member as normal procedure regards you. So on continue, you can calculate the fixed end moment due to external load, which is uniform distributed load. So you calculate, you can have your value there. After having your value, you can combine the effect of external load and the displacement or the internal load, which is due to settlement. So you can combine your moment there as the normal. So combination of moment you add depend on the support. So the value there, as you see here, this is the value. So combine it. After combining it, put it for the so-called moment distribution procedure, as we did before. The moment distribution procedure, it is a function of the support and the function of the distribution factor. After that, you want to find the final moment, as we did on the above examples. So the final moment can be now put. Now after putting the so-called the distribution factor, as we did on each support, now look, and this is the distribution factor and this is the fixed end moment after combining the external load and the settlement load. The moment you can combine, you can have every moment for each members, whether it is AB or BA or BC, after combining the moment. So after having the combination of the moment, and go and balance the moment as we did before. Find the unbalanced moment as we did before. So if you find the unbalanced moment at the joint, for example joint B, joint B, the sum this one times by -1 times by the factor. Now you shall have the value here, the value here. The same this point, you shall, after repeating the procedure, you shall have this value. The same this point, after times by -1, you shall have this point. After this one, do the carryover factor. The carryover factor, as you did before, it is factored by half of the value. So for example, if we have the carryover factor for the value here, it is times by half, get this one 600 from this one, this value here, if we times by half, we get this one, and this value here, if we times by half, we get this one, and this value here, if we times by half, we get this one, and this value, if we times by half, we get this one. After having it, the same procedure can go on. Sum this value here. If we sum this one, you can have a negative value because this is bigger, this is lower. The negative one, which you have times by a -1 also, you shall have a positive. The positive value times by its ratio, you shall have this one. Also the positive value times its ratio, shall have this one. The same to this joint here, joint B. This value you got here, this value, sum it. If we sum it, you have the unbalanced moment, which is a negative, because this is a -1 and this is negative. Of course, the negative value which you have, now from here, the negative value you have times by a -1. If you times by a -1, the value which you got times by this ratio here, you shall have this value. Also the same value times by this ratio here, you shall have this value. The same procedure you repeat to transfer the displacement moment. After having this value here, times by a half, you get this one, times by a half, you get this one. Repeat the procedure. Add this value. Add this value. This value here, add by 0 here. If you add it, you have 20.4, a positive value. In order to have a unbalanced one, this 20 should be times by -1. So if you times by -1, you have 20.4. Now the value here times by this ratio here, you shall get this one. And the value also times by this ratio, you shall get this one. So after that one, the same procedure here. This value added by 0, you shall have a positive value. In order to have the unbalanced one, should be this value times by -1. You shall have a negative value. The value which you get in negative value times by this ratio, you shall have this one, and the value also times by this ratio, you shall have this one. After having it, do the same procedure for the balancing. Balancing times by a half, times by a half. Repeat the above procedure until your value is going this to here. Until your value is going to here. After having a negligible value, now you can end your procedure, and what you can do now is to add the arithmetic value. The arithmetic value is this one. This value you created here, and this value. This value, if you see, is equal in the opposite moment, and there it is pin support. The pin support, it is hinged one, it allows rotation, so the moment is equal to 0. So if you add it, the value is equal to 0. The same above here, it is hinge support. If it is hinge support, it allows rotation. If it allows rotation, the moment is equal to 0. So the summation also here equal to 0. Here I shall have value, and the value here and the value here should be equal and opposite. It means if you add this value empirically, you add this one arithmetically, should have opposite value with this value here. So in general, the value here which you shall have at the end, as the end result here should be equal and opposite, because the support moment, it is carrying the equal and opposite moment. The same should appear to here. It's going to be should be equal and opposite. So having this value, you can create now your free end diagram in order to calculate now the so-called the reactions. So it means if you have your free body diagram like this one with its value of moment as you see, and the value of force, which is this one, so it is be easy and simple to take the moment. Say if you take a moment at this reaction, you can have equation with a known reaction here. So the same applied. If you take a moment here, shall have the unknown reaction here. If you take a moment here, you shall have a unknown reaction there. So take the summation of vertical load is equal to 0. So the summation of this load should be equal to 0. So if you take the summation of moment equal to 0, it means the vertical load should be with the summation of the reaction at the support. So you created the simultaneous equation. After creating the simultaneous equation, on solving the simultaneous equation, we will be able to have the value of the end reaction. The value of reaction at support A, reaction at support B, C, D, and etc. After having the reactions, we'll be able to calculate the shear force at your member. So on calculating the shear force for the member, will be easy to draw the so-called the shear free body diagram and the bending moment diagram. So on calculating it, the shear and the shear free body diagram, the shear and the moment diagram can be obtained, and you can have the value for the maximum shear at the support and the value of the maximum bending moment at the middle span. So by this value, you can be able now to go to design the reinforcement to withstand the bending moment and the shear at the support for the stirrup. So thank you for this tutorial. We shall meet for another tutorial. Thank you a lot. Thank you a lot. We are very appreciating your support. Thank you. Email us with Kirumbi Engineering Skills at gmail.com. Website Kirumbi Engineering Academy at ac.tz.